a line drawn parallel to one side. You can take any of the sides. Thales Theorem, which is also called as basic proportionality theorem, and it states that a line drawn parallel to one side. You can take any of the sides. In this case, I am taking parallel to BC. It divides other two sides in equal ratio. Okay, so the same line divides other two sides in equal ratio, because when you draw a parallel, definitely it cuts AB and AC, right, at certain points, D and E in this case. So the parts like AD by DB, that ratio is equals to AE by EC. We are not sure they are equal, but the ratio is equal. Okay, and what is given in this case? In triangle ABC, L is parallel to BC. This much is given, and to prove AD by DB is equals to AE by EC. That is what we are going to prove. For that construction we need, because we don't have any direct approach to prove that without any construction. So what I am going to do is, I just want to consider the ratio in terms of area, because the area formula I know of base into height. So therefore height I want to make it equal in both the cases. As it is one side, height is anyways equal for both the triangles AD and BDE. Similarly AED and CED, the other side. Okay, so that is how I'm just going to do the construction. Like draw DM perpendicular to AC, which is this one, and EN perpendicular to AB. Also join BE and CD. Without joining this, we wouldn't have got this denominators are equal, because these two triangles, we need to consider two triangles, which is BDE and CED, drawn on same parallels, and then drawn on same base and between two parallels. So this is what we want. So for that I am joining BE and CD as to consider a triangle also, and to get their areas are, to prove their areas are equal also. Proof: consider ADE by BDE, and then half base height, base is the AD, its corresponding height is EN, and here BD is as a base and its corresponding height is as well EN. Okay, and both cut, and AD by BD, that is first equation. Similarly AD and CED we considered, and corresponding base we have taken AE, height is DM, and its other triangle CED, CE as base, and corresponding height is again DM. So both cut, and we are left with AE by CE. And in this case, if you see in the two equations, numerators are representing same triangle, so their area is obviously equal, and denominators are drawn on same base, which is the DE here,